At the very foundation of calculus is this idea of how fast an object will change, how fast a quantity will change, how fast a function will change. And so what we've done at this point is we've been given this position graph of some object which is in movement. And from that position graph, we can calculate the velocity. We've done average velocity and we've done instantaneous velocity. And those velocities were measured in feet per second. But the reality is that it doesn't have to be a position function of a moving object. There's a lot of things that change in the world besides a ball being thrown through the air. Let's imagine a petri dish, and we're looking at the number of bacteria in the petri dish, and we're measuring how quickly or how fast the number of bacteria is changing. Or perhaps you're driving your car along the highway and you're looking at how much gasoline is your car consuming when we're going 50 miles an hour versus 75 miles per hour. The change of gas consumption can be considered. Or your mortgage, how much you owe on your house. And as interest rates change, how quickly can you pay down your house? Or if you add a little bit of extra money to your monthly payment, how is that going to change the length of time before your house is paid off? All of these things measures change, and not only do they have a function associated with them, but there's also a graph that gets associated with it as well. So up until this point, we've been doing an average velocity from a to a plus h on some position function, and we say that the average velocity is s of a plus h minus s of a over h. And at this point in time, you should be very comfortable with that formula for average velocity. But we're going to make this a little bit more general. We're going to not say that this is true for just a position function. We're going to say that you can calculate an average rate of change for all functions. And so here's the definition of an average rate of change. We say for any function f, which is the most common name for a function, the average rate of change of f on the interval from a to a plus h is given by the value f of a plus h minus f of a over h. And you'll notice that that looks very similar to the average velocity because they're basically one and the same, except an average velocity is used primarily for a position function, where an average rate of change, which we're going to denote AROC from a to a plus h, is used for any function whatsoever. Now, equivalently speaking, if we want to calculate the average rate of change, let's say from a to b, instead of a to a plus h, if we want to go from a to b, then it follows suit that the average rate of change from a to b is simply going to be f of b minus f of a over b minus a, and you know that this gets paired up with the concept of a slope of a secant line going through the points on the graph a f of a and b f of b.